Hello and welcome to this video in our R Analytics course. In the previous video, we learned about different data types in R and how this data is stored in variables. We also looked at how R can be used to perform simple mathematical calculations. Finally, we also then learned about the various packages that are most commonly available in R. In this video, first we will look at some of the numeric functions available in R. Later, we will learn to download and install R packages. Let us first open a new script. We learned to do this in the previous video. We can also use the keyboard shortcut Ctrl plus Shift plus N. Let us save this file as basic numeric functions. The variables and the values we assigned to these variables in this previous video are still appearing on the global screen. If we wish, we can clear these from memory. Say we define a variable x and store the value 10 in it. Now we wish to remove this value and store a different value in the variable. We can do that by simply assigning another value to that variable, say 5. Now if we check the value of the variable x, we see that it is 5. If we want to completely remove the variable itself from memory, then we can use the function rm, remove from memory. In the parenthesis, we write the variable which we want to remove. So write rm x. Now if we check the value of x, we see that it says object x not found. This is because it no longer exists in memory. Let us store the value 5 in the variable x. Let us look at the numeric functions that can be used. The first one we can use is the square root function. We write sqrt, acronym for square root, and in parenthesis write x. We see that the square root of 5 is populated in the console. Let us look at another function called absolute. Define another variable y that takes the value minus 12.5. Now write abs and in parenthesis write y. Press Ctrl Enter and we see that the absolute value of y, that is plus 12.5, is populated in the console. Another numeric function that can be used is round, which is used to round off a given number to a given number of decimal places. Say we assign the value 12.78 to x. Use the function round. This has two parameters, value and digits. Value is the number that we want to round off, which for us is the value stored in x, that is 12.78. And digits is the number of decimals we want after rounding off. Say we write 0. In this case, round will remove all the decimals and give us the nearest integer to 12.78, that is 13. Another function that is available is ceiling, which returns the nearest integer greater than the number we are considering. Write ceiling of x and press Ctrl Enter. We see that it comes out to be 13. Opposite of this function is floor, which rounds off the decimals to the nearest integer below the number we are considering. Another such function is trunc, which truncates a numeric value by simply removing the decimals. There are a lot many more numeric functions. Functions such as minimum, maximum, range, standard deviation and all can be used when we have the data set for which we can calculate these statistics. For these we need to store more than one value in the variables we are creating. Let us see how we can do that. Say, we write x is equal to 1, 2, 4 and press Ctrl Enter. It gives us an error. It is not able to store these multiple values. Let us see what we have to do in order to store multiple values in a variable. The very first data structure for storing multiple values is a vector. A vector is denoted by the alphabet C. So if we write the variable x is equal to C and in parenthesis write the multiple values we wish to store, press Ctrl Enter. Now these numbers are stored in the variable x. If we write x and press Ctrl Enter, we will see that all the three values are now stored in it. Say we write x is equal to C, in brackets write 1, 3, 4, 5, 6, 8, 9, 10. Now check the value of x and we see that all these numbers got stored in x. In the same way, characters can also be stored in the vector form. Write y is equal to vector ABCD. Remember to put these values in quotes as these are character values and hence will only be recognized if they are inside quotes. Now let us define a vector z, which has both numeric and character types of data. Press Ctrl Enter. We see on the global environment window that all the values are converted into characters and z is stored as a character vector. Please note that if numeric and character data types are mixed, then the entire output will be converted to the character type. Let us pay attention to the global environment window. Let us try to understand what is meant by numeric 1:8, character 1:4, character 1:4. This shows the index of vectors x, y and z, that is the number of values stored in them. Let us see what is the use of this. Say we want to check for vector x, what is the third value stored in that vector? Write x and in square brackets we write 3 because we want the third value. Hence we get 4 as the value 4 is the third value stored in x. Similarly, we can determine the fifth value in x, which is 6, and the eighth value, which is 10. If we check for the ninth value, it says not available as only 8 values are stored in vector x. Now let us see some functions which can be used on these vectors. Write x and in square brackets write x greater than 5. Press Ctrl Enter. We see that this generates the values stored in vector x which are greater than 5. Here greater than is a relational operator that we mentioned in our previous video. Let us try with more than one condition. Write x in square brackets x greater than 4 and x less than equal to 8. Here we are using a logical operator AND, which we had mentioned in our previous video. This tests both the conditions, that is, values stored in x which are greater than 4 and less than equal to 8. We can see in the console that the values 5, 6 and 8 are generated there. Let us use another numeric function which can be applied on vectors. Min of x. This finds the minimum value from all the values stored in x. We see that it generates the value 1 in the console as the output. For this numeric function, we need a minimum of 2 values to be stored in a variable, and of those 2 values the minimum would be found. Opposite of this function is max of x, which gives 10 as the answer. Mean of x gives the average of all the values stored in x, that is 5.75. Sum of x gives the total of the values in x, which is 46. If you ever come across a function in R but do not know what its purpose is or what it could be used for, then simply just put a question mark and write the name of the function and press Ctrl Enter. We see that in the bottom right window, a description of the function comes which explains the usage, the arguments and details of the function. It also tries to explain the function with the help of a few examples. Other than through a vector, multiple values can be stored in a variable in an alternate way. Write x is equal to 1 to 12. We can check the value of x both in the console and the global environment and see that it is all the numbers ranging from 1 to 12. This colon symbol is called a sequential operator, which is one of the miscellaneous operators present in R. Now say we want to generate a sample of 5 values from the values that are in X. We write sample in brackets X, which is the first argument denoting the population from which we want to derive our sample, and the second argument is the sample size, which is 5. Here we are getting a brief overview of how we deal with samples, and we will be generating samples in our later videos from big data populations. If we generate another sample of size 5, we see that the sample generated this time is different from the sample we first generated. This shows that the samples generated in this way are purely random. So far we have seen the use of very basic formulae, which most of us would have been aware of through our prior knowledge as well. To deal with bigger formulae, we will also need bigger datasets, which we would not always be manually entering on R like we have been doing so far. Till now we are assigning and storing values and variables on our own. However, usually we will take this task from elsewhere and import it into R using one of the packages we discussed in our previous video. Let us now try to import some data from an Excel file. For this, we have a very useful function. It is called read.xlsx. However, as discussed in the previous video, functions are made available through packages which must be installed beforehand to be able to avail all the functions one needs. If we go to the Packages tab on the bottom right screen, we get the user library, which enlists all the packages that the user has installed. We have installed the package readxl, which is why this function will work for us. You might have to download this package if this does not already exist in your user library. Let us learn how we can download a package that does not exist in the user library. The first way to do this is to click on the Install button on the Packages tab. In the Packages option, write the name of the package. Say we want the package dpylr, which helps in manipulating data. We write its name and click on Install. We see that it starts getting installed. For this, please make sure that a working internet connection is in place, as these packages are downloading from the CRAN directory, which is a server on the internet. We can see on the console it says that the package has been successfully installed. If there are some other packages which this package is dependent on, then R will also download these for you automatically. Let us try downloading XLSX also. We select this package in our library and delete it. Once we restart RStudio, XLSX will not appear in our library. To install it again, one method will be to go to the Install button and download it. We just saw how to use this method. Let us look at an alternate method to do this. Write install.packages and within quotes write the name of the package we want. Press Ctrl Enter. Since we just removed it and did not restart R, it is giving us a prompt to restart R before installation can complete. We will not lose any data in internally restarting R. we can see that R has been restarted. Finally, we can see that the package xlsx has been successfully installed. Hence, we can write this code and install a package, or alternatively, we can click on the install button and write the name of the package we want to install. We can see it here that the packages are installed from the CRAN repository, which is a server where all the data packages created are stored. More than one package at a time can also be downloaded by simply writing the names of all the packages separated by commas. In the code also, we can write multiple names separated by commas. Even though we have installed the package, it is still not ready to be used. Let us see how we can do that. Write library xlsx inside parenthesis. Now the package is ready for use. Let us now try to import an Excel file. We have this Excel file named final report whose data we wish to import. To import this file, we need its file path. To do this, we go to the folder where the Excel file is. Press the keyboard shortcut Windows+R. The Run window will open. Drag and drop the concerned Excel file into the Run window and we'll see that the file path automatically appears. We will copy this path. Come back to RStudio. We will now use the command to read this file in R. Write read.xlsx. In the parenthesis, we need to give 3 parameters. First parameter is the file path. Paste the file path that we earlier copied. Second parameter is the sheet index, that is, what sheet number do we wish to read the data from in the given Excel file. We write 1 because we want the data to be pulled out from the first sheet. For the final parameter, write header equal to true. Please note that this is case sensitive, hence do not write true in the lower case. This is a logical value. If we choose its value to be true, then the first row of the Excel sheet is used as the names of the variables in R. We see that it shows an error that it does not recognize / and D. This is because file paths in R need to have / and not /. Once we replace these and press Ctrl Enter, we see that our data has been imported. However, we do not need to write the full file path each time we have to call data from this file. We can create a variable, say myFile, and we can equate it to the read.xlsx function. Finally, let us clear the console by using the keyboard shortcut Ctrl+L. Now if we run this code, the read.xlsx function gets executed. And we are able to get the data from the Excel sheet. We see that this variable now appears on the global environment window, and we can see that it shows there are 160 observations under 8 variables in this data. Now if we write myFile and press Ctrl Enter, we see that the data from the Excel sheet gets generated on the console. This is how we import and read data files from Excel into R. In the next videos, we will learn how to store this data in the form of other data structures such as matrices, lists, arrays, factors, and data frames, and subsequently use it to perform further calculations. Thank you.